Right. Let us start. See this question, all of you. Once see this question. The variation of molar lambda m. M stands for molar conductance. Molar conductance of acetic acid with the concentration is correctly represented as. Anybody? The variation of molar conductance of acetic acid with the concentration is correctly represented as. For weak acids, what will be the graph? For weak acids. For weak acids, rectangular hyperbola. Okay, rectangular hyperbola. Look at this one. Correct only, no? This one or not? Online students. Online students. Is it visible to you? All of you, please respond. Hello. See, for weak electrolytes, I already explained, graph will be like this. Okay. For strong electrolytes, graph will be like this. Right. Next question. Next second question. Which of the following solution will have highest conductivity? Which of the following solution will have highest conductivity? See, conductivity is directly proportional to number of ions. If number of ions are more, then conductance is more. Okay. First of all, look at this concentration. Concentration is 0.1 molar, 0.1 molar, 0.1 molar, 0.1 molar. Right? Concentration is same. In this case, we will split this salt, CH3COO negative and H plus. But acetic acid is weak acid or not? So we will get less number of ions. We will get less number of ions. Weak electrolyte. Weak acid is a weak electrolyte. 0.1 molar NaCl, this is a strong electrolyte. So you will get more number of Cl negative and sodium plus ions. Here also you will get more number of K plus and NO3 minus. Here also you will get more number of H plus and Cl negative ion. Now, molarity is same, so you will get same number of ions. For example, if you get a 50 Na plus and a 50 Cl negative, that is equal to 100. Here also you will get same 100. Here also you will get same. So you are getting same number of ions. You are getting same number of ions. Why? Because 0.1 molar is given same concentration. Then on what basis we can predict the conductivity? On what basis we can predict the conductivity order? See, if ion is small, its mobility is more, its mobility is more, its moment is more, its moment is more. Sodium ion, potassium ion have H plus, which is having smaller size. First year group elements, 1A group, hydrogen, lithium and sodium, which is having smaller size, online students. H plus, Li plus and Na plus, which is having smaller size. H plus is having smaller size. If size is small, mobility is more, moment is more, then conductor more current. Okay, smaller ion conductor, more current. So what is the answer? 0.1 molar HCl is the correct answer. Clear? Very important. H plus ion's size is small, mobility is more, conducting capacity is more. Okay, got it. Next question. These are very important. Okay. JE means questions. These are theoretical questions. Which of the following statement is incorrect? Which of the following statement is incorrect? Last time question came from the second part in the last NEET. So this time we may get a question from the first part. That's why I started first this only. Clear? If you get a numerical based, then you can do directly by substituting the formula. But when you get the concept based questions, then you may get confusion. So listen carefully, all of you. Which one of the following statement is incorrect? Incorrect statement you have to identify. First one, specific conductivity decreases with dilution. You have to select incorrect. Sorry, incorrect. Incorrect. This is correct or first statement? Specific conductivity decreases with dilution. Yes, what is the reason? In that specific area, what I explained. For example, this is a specific area, Na positive, Cl negative. When you add water, what happens? Water washes the ions from this specific area. This is 1 centimeter cube area. After adding water, ions will move from this place to this place. To give this diagram, there is no ion after adding water. So in that particular area, number of ions are decreasing. So specific conductance decreases. I already given this point. Right, next. Equivalent and molar conductivities increases with dilution. What is the formula? Mu is equal to specific conductance into 1000 by molarity. Lambda is equal to specific conductance into 1000 by normality. I given already. From these two, mu is inversely proportional to concentration, molarity. Lambda is inversely proportional to normality. As you increase the concentration, conductance decreases. Equivalent molar conductivity increases with dilution. Yes. Dilution means decreasing the concentration, right? If you decrease the concentration, conductivity increases. Second statement also correct only. This is correct, this is correct. Not incorrect statement. Third one. Lambda infinity for weak electrolyte cannot be found by extrapolating the graph between equivalent conductance and concentration. Yes, this is correct. See, you know the shape of the graph. For weak electrolytes, it will present like this only, right? Extrapolating, see, if you extend this, you want to touch this axis, right? Clear. Instead of that, if you have graph like this, if you extrapolate, then you will meet this axis. For weak electrolyte, extrapolation means if you extend the graph, you cannot get this, you cannot touch this line y-axis. So you cannot calculate for weak electrolytes. Clear? For strong electrolytes, if you extrapolate, you will get some value. Clear? So for weak electrolytes, if we extrapolate, we won't get the values. Correct. For weak electrolyte cannot be found by extrapolation. That is also correct only. Correct. So if you get this type of situation in the exam, don't read this. Okay, this will be the answer. General trick. Okay, first three options are correct. What is the question? Incorrect. Don't read. Till time saving process. Answer it directly. Now coming to this. Molar conductivity of strong electrolyte increases with dilution because of ionization increases with dilution. Very conceptual based question this is. This is incorrect statement. Why? Why this is incorrect statement? Molar conductivity of a strong electrolyte increases with dilution because ionization increases with dilution. See, strong electrolyte means it undergoes complete dissociation. For example, take a beaker, put some salt and add some water to it. For example, if you add some 500 ml water, all the salt undergo dissociation because that is a strong electrolyte. You added 500 ml water. Now what you are doing, you are adding another 500 ml water, means you are diluting more further. Now conductance increases due to increase in the volume, due to increase in the free space for the movement, not due to dissociation. Already, whenever you add 500 ml at the beginning, then only total salt underwent dissociation. When you add new water, there is no salt to undergo dissociation. Already, for the first step, when you add first volume, then only total salt will undergo dissociation. Why? Because that is a strong electrolyte. Then how conductance increases? Due to increase in the volume, due to increase in the more space for the movement. That is the reason, not due to ionization of the electrolyte. Got it? First you took some salt in a beaker. You added 500 ml water. For that 500 ml total salt underwent dissociation. No more salt will be present. Clear? When you add further another 500 ml water, why conductance increases? Not due to dissociation of old electrolyte. That is due to availability of the volume for the movement, free space. Clear? Super question, conceptual question. Clear? Right. Next one. Which of the following statement is wrong? Which of the following statement is wrong? K plus has different molar ionic conductivity at infinite dilution in KCl and KBr. Any guess, online students? Any guesses? See, this is KCl solution. KCl solution. Let us consider its size is, potassium size is some 1.2 picometer. Take another solution, KBr solution. In this, potassium size is 1.2 picometer. Irrespective of the type of this salt, what is the size of the potassium? For example, take one atom, attach that atom to another atom B, attach that same atom to another atom C. Will its radius decreases? For example, say hydrogen atom is there, okay? Hydrogen is attaching with chlorine. Here hydrogen is attaching with some fluorine. Will hydrogen atom changes its shape or size? No. Irrespective of the surrounding atom, hydrogen property do not changes like radius. Clear? Similarly, potassium ion size is the same in KCl and in KBr. How its size changes? Size do not changes. If size is constant, then conducting power also same, constant. But what is the statement? K plus has different molar conductivity at infinite dilution. Wrong. Not different. Same conductivity in the KCl and same conductivity in the KBr. How much current it carries in KCl? Same amount of conductivity will be carried by potassium ion in the KBr also. Clear? Because there is no change in the shape of the potassium ion. Got it? This is also very important question. This is the wrong statement. This is the wrong statement means remaining 3 statements are correct only. Na? Once have a look at that remaining statements also, all of you. Please respond. రైట్ ఒక్కసారి అది గ్రూప్ ఓపెన్ చేయండి. ఇక్కడ మీకు అది ప్రింటింగ్ సరిగ్గా లేదు కదా, గ్రూప్లో చూడండి ప్లీజ్. వన్స్ వాచ్ ది ఓపెన్ ద పీడిఎఫ్ ఆల్ ఆఫ్ యూ. Sweta, are you there? Hello, Sweta. Sweta. The specific conductance of 1 molar sulfuric acid is 0.26. The molar and equivalent conductance. This is the question. Open the PDF in your group, all of you, or you can see the board also. Now I am writing the question, equivalent conductance of this. Tell me. This is the question. What is given to you? Specific conductance of 1 molar sulfuric acid is given 0.26 Siemens centimeter inverse. The molar and the equivalent conductance of the solutions. Pragnika, try chestava now. Sweta, are you there? Madhiha, can you try? Priyanka, Madhiha, Preetika, Sanjana, can you try this question? Anybody? Second option. 260 and 130. Is it correct? Akshara, try chestam. Formulas చూడలేదు కదా నువ్వు. ఇప్పుడు కూర్చొని చదువు ఫార్ములాస్. చూసావా? Other students, please respond, all of you. Other students, once look at the solution, all of you. What is given to you? The specific conductance of 1 molar solution is, specific conductance means K. K is given to, K is equal to 0.26 Siemens centimeter inverse. Siemens means ohm. Ohm inverse centimeter inverse. Okay, Siemens means ohm inverse centimeter. K is given to you. Okay, Then find first molar conductance. Molar. What is the formula for molar conductance? Molar conductance mu is equal to specific conductance into 1000 by molarity. This is mu. K value is 0.26 into 1000 divided by what is molarity? What is molarity? Molarity 1. So how much you will get? 260. Okay, first one 260. Second one, equivalent conductance is equal to specific conductance into 1000 by normality. But see, normality is not given, Akshara. What is given to you? Molarity. Then how to find normality? Tell me. How to convert this normality into molarity? N factor into molarity. Normality is equal to N factor into molarity. In place of normality, you can write N factor into molarity. Okay. Now substitute the values 0.26 into 1000 divided by N factor for sulfuric acid. H2SO4. 2 hydrogens it will give, and molarity is 1. Okay. 1 and 3. So 0.13 into 1000. That is equal to 130. You can do directly. If you are able to do, you can do. The molar conductivity is at infinite dilution. Infinite dilution of AgNO3, NaNO3 and NaCl are 116.5, 105.2, 110.3. The limiting molar conductivity of AgCl. See, what is the application of Kohlraasch law? What is the application of Kohlraasch law? By using Kohlraasch law, we can find the conductivity of weak electrolyte at infinite dilution by using the conductivities of strong electrolytes. First of all, I am writing the conductivity at infinite dilution. Lambda infinity of AgNO3 is equal to what is given 116.5. Lambda infinity of NaNO3 is equal to 105.2. Yes, tell me, Sophia. Second option. Yes. 3 strong electrolytes are given. This is Kohlraasch law application. You will get 3 strong electrolytes data and 1 weak electrolyte will be given to you. You have to find the conductivity of that weak electrolyte. Very simple question this is. First of all, tell me in these 3, among these 3, which is not having common ion with AgCl. Which is not having common ion with AgCl. First of all, tell me Ag present here, Ag present here. For which salt we are going to calculate conductivity? For AgCl. Compare which is not having common ion. Ag, common is there, no? Yes. Cl, common ion is there or not? Yes. But in NaNO3, is there any common ion? No. Over. Question is over. Add the 2 salts which are having common ion. Subtract this salt which is not having common ion. That is the trick. So lambda infinity of AgCl is equal to add 1 and 3. Okay, lambda infinity of AgNO3 plus lambda infinity of NaCl. These 2 are having common ion. Subtract the one without common ion. NaNO3 is not having common ion. NaNO3. Now substitute the data. Equivalent conductance of AgCl is equal to AgNO3 value 116.5, NaCl value 110.3 minus NaNO3 value 105.2. Add all and subtract this 105 value. Approximately also you can say, because option to option large gap is there. Now you can take approximate values or you can add points also. How much we are getting? 116.5, 110.3 means this is 8 This is 6, 226.8. 226.8 minus 105.2. How much? 8 minus 2, 6. 6 minus 5, 1. Here 121.6. Second note. Okay, right. Next question. You can see the group. Okay, if you get any confusion in reading the question. Right, 0.02 moles of acetic acid is dissolved in 200 ml of water. Its specific conductance is 5.46 into 10 power minus 4 Siemens centimeter inverse. The ionic conductance of H plus and CH3CO minus are given to you. The degree of dissociation alpha. First of all, what is degree of dissociation formula? Degree of dissociation alpha is equal to conductance at any concentration by conductance at a infinite dilution. Lambda C by lambda infinity or lambda C by lambda 0. Okay. Once observe this value, the ionic conductances of H plus and acetate ions are given to you. What is Kohlrausch law? According to Kohlrausch law, the equivalent conductance of weak electrolyte at infinite dilution is the sum of the conductances of the individual ions. According to Kohlrausch law. See, acetate ion conductivity and H plus ion conductivity is given to you. Add both the conductivities, then you will get the conductivity of acetic acid. This is only the Kohlrausch law. The sum of the conductivities of the ions is equal to conductivity of the particular electrolyte, weak electrolyte. I already given about Kohlrausch law. Now, right, add the conductances. H plus is 3. So reverse I am adding now. 349.3 and 40.7. Add these two. Tell me answer. 349.3, 40.7. How much? 7, 3, 10, 9, 1, 10, 4 plus 4, 8, 9, 390. 390 is the conductivity of weak electrolyte at which dilution? Infinite dilution. H infinite dilution. So we got lambda infinity. Lambda infinity calculation is our equivalent conductance of acetic acid at infinite dilution. Lambda infinity is over. If you know lambda C, then you can find a degree of dissociation. Once watch the videos if you have still confusion on the concept. Okay, Kohlrausch law. Next, how to find lambda C? Equivalent conductance. What is the formula for equivalent conductance at any concentration? Lambda C is equal to specific conductance into 1000 by molarity. You tell me specific conductance. If it's a specific conductance is 5.46, K is given already. But do we know molarity? We don't know molarity. We know K, but how to find molarity? By using the data. Moles are given and volume also given. So find molarity. K is already given to you. So K is equal to 5.46 into 10 to the power of minus 4. And finding molarity. What is molarity formula? Molarity is equal to number of moles by volume. This is based on the stoichiometry. Molarity formula. Molarity is equal to number of moles by volume in ml into 1000. Right? Number of moles, how many given to you? 0.02. And volume is 200. 200 into 1000. Right? How much you will get here? 5 times. Okay? 5 into 0.02 means molarity is equal to 0.1, 0.1. Now you can get a lambda c. So lambda c is equal to 5.46 into 10 to the power minus 4 into 1000 divided by molarity 0.1. Simplify this. See, here 0.1 is there. Take this to numerator. It will become 10. 10 power 4, 10 power minus 4. So finally you will get 5.46. 5.46. This is lambda c. Lambda c value 5.46. And you know lambda infinity also. Look at this. Lambda infinity. Now what is alpha? What is alpha? Lambda c by lambda infinity. Lambda c 5.46 divided by lambda infinity is 390. 390. If you simplify, you will get 1.4 into 10 power minus 2. You can check if you have any doubt. Okay, simplify this, you will get this value 1.4 into 10 power minus 2. But see the procedure, very good question. This is from the first part. We should do practice. Okay, Pragnika, follow Tunara. Hello. Hello. Take screenshot. Take screenshot all of you and practice today only, right? First day, more 20 days are there now. So today only everyone should complete these. I sent already PDF, right? Try again and again. Next question. I am not giving the time for the copy. Take screenshot and go for next question. Because time is not sufficient. Next, the specific conductance of certain monobasic peak acid. Certain monobasic peak acid is 0.1. At 0.1 molar is 5 into 10 power minus 3. First of all, underline what is given to you. See this value. This value is specific conductance K. And molarity given to you. This is KH. Molarity also given to you M. Its degree of dissociation. Alpha you have to calculate. See, in the last question, actually we calculated this one, but in this question they already given. Okay. In the last question we only calculated this, but here this is given directly. First of all, write the data. Molarity is equal to 0.1 molar. Specific conductance K is equal to 5 into 10 to the power minus 1. Specific conductance is given. Next, it's a molar conductance at infinite dilution is. Molar conductance means mu infinity. 10 to the power of minus 3. Answer.
10 to the power minus 3.
Oh, 5 into 10 to the power minus 3. And mu infinity, its molar conductance at infinite dilution is 200. 200 Siemens centimeter square mole inverse. Siemens centimeter square mole inverse. What you have to calculate? Alpha question mark. What is the formula? Conductance at any concentration by conductance at infinite dilution. Lambda is equal to mu c by mu infinity. In the last case, we used that another form. Lambda c by lambda infinity. Here, mu c by mu infinity. Mu c by mu infinity. Tell me, do we know molar conductance mu? Do we know molar conductance? No, we don't know. We know molarity only, but we know molarity, we know specific conductance. We don't know about the mu c. Now calculating mu c. Specific conductance into 1000 by, tell me, 1000 by molarity. You will get mu c. Already mu infinity is there. K value 5 into 10 to the power minus 3 into 1000 divided by molarity 0.1. Then how much you will get after simplification? 0.1 means you will write 10 here. 3 zeros and minus 3 will get cancelled. So you will get 50. You substitute in the formula alpha is equal to mu c by mu infinity. 50 divided by what is mu infinity? 200. 1 by 4. 1 by 4 means 0.25. Third option. Okay, online students. Everyone, please tell me. Madiha, Pragnika, follow Pragnika. Follow లేదా తేజస్విని నువ్వు తేజస్విని ఈ క్వశ్చన్స్ మీరందరూ మళ్ళీ చేయాలి. సంజన మీరు ఈరోజు మళ్ళీ చేయాలి క్వశ్చన్స్. అట్లీస్ట్ మీకు ఫామ్లా ప్రాక్టీస్ అవుతుంది. రికార్డు ఉంది, కావాలంటే పంపిస్తాను ఆల్రెడీ. అవి హెల్ప్ తీసుకొని చేయండి. నెక్స్ట్ క్వశ్చన్. అందుకని ఇప్పటి నుంచైనా మీరైనా ఎవరైనా, నువ్వైనా కాదు, ఇంకా 2 లెసన్స్ ఉన్నామని కాన్సెప్ట్ వినండి. 1 షాట్ లాగానే చెప్పేస్తాను. న్యూమరికల్ చేద్దాం. మీరు కాన్సెప్ట్ ఏం వినలేదు అనుకోండి, ఫామ్ని ఎట్లా సెలెక్ట్ చేస్తారు? మిగిలిన 2 ట్రై చేద్దాం. లాస్ట్ టైం అయితే ఈజీగానే వచ్చినాయి, ఈసారి కూడా ఈజీగానే వస్తాయి. ఇంకొక 2 మన ఫస్ట్ ఇదే సొల్యూషన్స్ అయిపోయిందని, సొల్యూషన్స్ స్టార్ట్ చేయలేం కదా. సో సొల్యూషన్స్ ఐ హ్యావ్ టు టీచ్ అండ్ కైనెటిక్స్ ఆల్సో. నెక్స్ట్ క్వశ్చన్ మార్చాను నేను, మార్చలేదు మార్చాను. రైట్, నెక్స్ట్. దిస్ ఈజ్ electrolysis questions. Electrolysis questions are very easy, I think, for you. Not easy. Vaishnavi, can you try this question? You read already electrolysis now? Can you try that? On electrolysis of dilute sulfuric acid between platinum electrodes. Platinum is which electrode? Inert or active electrode? You have 2 inert electrodes, platinum and graphite. Remember, platinum and graphite. On electrolysis of dilute sulfuric acid between platinum electrodes, the gas evolved at anode is dilute means water also present. Aqueous, dilute in the sense aqueous H2SO4. First to dissociate this, H2SO4 dissociates into 2H plus and SO4 minus 2. Water also there, no? Aqueous, dilute, aqueous, all are same. At cathode, see, you have only one cation. And how many anions are there? 2 anions are there, sulfate and OH minus. Which is having low discharge potential? ఒక్కొక్కరిని తన్నాలు అసలు పట్టుకొని. లో డిశ్చార్జ్ పొటెన్షియల్ మిమ్మల్ని చదవండి అని చెప్పాను నేను ఆల్రెడీ. OH minus is having low discharge potential, right? So OH minus undergo oxidation at anode. Which is having low dP1. See the order, OH minus. What is the product when OH minus undergoes oxidation? What is the product? Tell me. Oxygen gas. అన్నీ అయిపోయినాయి. నేనైతే ఎంత బాగా ఫాస్ట్గా చెప్పినాను, మరి అయిన ఎక్కడికి పోయినాయి. మన పాత వాళ్ళనైతే నేనైతే మీ కేర్ తీసుకొని మరీ చెప్తున్నా, కానీ అంటే ఎక్కలని కాదు, నాకెందుకు అట్లా అనిపిస్తుంది, మీరంతా బాగా రెస్పాండ్ అవ్వట్లేదని. సరే, మళ్ళీ ఒకసారి గుర్తుపెట్టుకోండి ఇప్పటికైనా. OH minus when undergo oxidation మీరేం చేయదు, ఆక్సిజన్ గ్యాస్ విల్ బి లిబరేటెడ్ అనాలి. అట్లీస్ట్ ఇది గుర్తుపెట్టుకోవాలి అక్షర. OH minus when undergo oxidation, what is the product? Oxygen. You no need to learn total equation, clear? Just remember O2 gas will be liberated when OH minus undergoes oxidation, clear? So what is the answer? The gas evolved at anode is O2 over. At cathode only one cation is there, so H2 gas will be liberated. Right, next. Electrolysis of aqueous solution of NaOH between platinum electrodes. Again, platinum means inert electrode, we should follow discharge potential order. Aqueous solution, aqueous NaOH, dissociate aqueous NaOH, aqueous NaOH dissociates into Na plus and OH minus, H2O dissociates into H plus and OH minus, right? At anode, first of all write product at anode. How many anions are there here? So there is no problem, you can do directly. 4 OH minus gives rise to 2 water molecules plus O2 plus 4 electrons. Clear oxygen gas is liberating. Oxygen is liberated at what? At anode. Now coming to the cathode. At cathode, between these two, which is having low discharge potential? Na plus and H plus, which is having low dP? H plus is having low discharge potential. So H plus undergoes reduction to produce H2 gas. H2 at cathode and O2 at anode. This is the answer. First option. H2 at cathode and O2 at anode. Okay. I know, but ఎందుకంటే వాళ్ళకి సెండ్ చేస్తే చూస్తారు. నెక్స్ట్ వన్, electrolysis of certain liquid resulted in the formation of H2 at cathode and Cl2 at anode. The liquid is electrolysis of certain liquid resulted in the formation of H2. What is the answer, Sophia? Tejaswini? Which gives H2 at anode, H2 at cathode and Cl2 at anode. Pure water do not undergo electrolysis. Ions are not there. Current is passage is not possible. We take pure water. Can we pass the current to it? No. It won't conduct. Absence of ions. Acidulated water can allow the current. Acidulated means take pure water, just put some drops of acid, then pass the current, then it goes. Or put some salt in pure water, then it will conduct current. But if you take only pure water, it won't allow current due to absence of ions. Second one, NaCl. Check NaCl. Vaishnavi. Aqueous NaCl. How it will dissociate? First NaCl dissociates into Na positive plus Cl negative. Aqueous means water. Water dissociates into H plus and Cl negative. At anode we will write anions. Anion is common or not? Anion is common. So Cl negative undergo oxidation to produce Cl2 gas. Oxidation means loss of electron only, na? H plus and OH minus. Here or here? Sorry. Mistake this. Good. OH minus and Cl minus, which is having low dP. Cl minus is having low discharge potential. That's right. Product is correct only, but here I confused. This is OH minus. Clear? At anode, Cl2 gas. At cathode. What are the cations? Na plus and H plus, which is having low dP. So what is the answer? Sorry, electron. Gives rise to half H2. Aqueous NaCl is the answer, or NaCl solution in water. Right, next question. Next one. The reaction among the following that takes place at the anode when aqueous AgNO3 is electrolyzed between Ag electrodes. Very, very important. Ag is which electrode? Active or inert electrode? Silver is which electrode? Given the code also. Zinc, Ca, Sil. Zinc, copper, silver. Zinc, Ca, Sil. Active electrode. When active electrode is given, what is the procedure? What is the procedure? At anode, how to write the reaction? Right, given one trick also. Whenever active electrode is given, to write the product at anode, what we have to do? What we have to do? At anode, which active electrode is given to you? Which active electrode is given to you? Silver is given to you. Take active electrode and remove electrons from it. Simple thing, very simple. Active electrode will be mentioned or not in the question. Take that active electrode, remove electrons from it. Take active electrode and remove electron from it. That is only the reaction at anode. Correct or not? Recently also explained. We did questions also on this. Right? Online students. Correct only now? When active electrode is given, how to write the reaction at anode? Take that active electrode and remove electrons from it. Next, in which of the following? In which of the following process of electrolysis Cu gives rise to Cu plus 2 electrons. Cu gives rise to Cu plus 2 electrons. Online students, can you able to see the board? Online students. Right, just now I explained. When we remove electrons from the metal, when active electrode is mentioned, fused copper sulfate using platinum. Platinum is which electrode? Inert electrode. Aqueous copper sulfate between copper electrodes. Aqueous copper sulfate between copper and anode. Where inert is mentioned. Only active copper. So third option. When active electrode is given, then we take that active electrode and we remove electrons.